Right, we start off with a raw casting. That's it, as it comes to me. Then what we do, put it in the lathe. Can you zoom in on the lathe? Using a known true surface. We know that that is concentric to that, so we use that one to start off. The 3-jaw chuck, tighten it up. And now what we're going to do, we're going to put a spigot on it. And this is how we do it. So what we do first of all is we check that's going to be the length of the spigot. Start the lathe. That goes to 0. The lathe is now locked in that position and we've set that at 0. Repeat that as many times as the amount of wheels that you want to do, i.e. 6 times for a 6-coupled loco. I'm not going to do all 6. The next operation, we've got that now as a spigot. Needs to be as big as you possibly can, so you've got plenty of purchase. Place that in the 3-jaw chuck and tighten to that. You just rotate it, make sure it's secured properly. You can actually see little marks where the chuck's been before, and we tighten that up. What we're going to do now is take the face off the front, and the crank is 0.5 millimeter proud of the actual tread face. So that's the next operation. Come back, that's your second operation. You do repeat that on all the wheels. Now the next operation is to put the tread on, and by doing how we do the tread is we don't that is the tool that we're going to use to put the tread on. I'll show you when it's in that position. So what we do is we release the 2 screws that hold the compound slide, and we then set the compound slide over at 3 degrees, and that's what we require, and that is the same angle as it is on the real wheel on a locomotive. We then wind in, we back the compound slide off 2.5 millimeters plus 1/10 of a millimeter. We then bring it in and touch near to the corner as we can on the tread or on the wheel. We then do a quick measure to make sure that you've got it. That's fine. That's within guild standards. So now we need the diameter. The diameter of this wheel is going to be 6'8.5", which gives us a dimension off my little chart, which you can see, which is 6 foot, which is 42, plus 4.5, so that's 42, 46.5. We'll do it, yeah, 46.5 is fine. You don't want the driving wheels too large in diameter because we are slightly overscale as a model using the digital caliper. So we need to take off approximately 3/4 of a millimeter. We'll take that off and then we'll get it down to the correct size after that. So we set the dial and we come back. That's 1/2 millimeter. That's correct there. We can finally do it as we get that a little bit closer. Check it again. Make sure. That's, oh dear, should have wrote this down. Yeah, that's right. Yeah, just under 47 we'll do it. So we'll take a cut off. It's always best check it as many times as you can. That's fine. 46.37. You repeat that dimension, then you zero the dial, and that's fixed. But before you don't take it out at this stage. What we do now is we put the hole in the centre. The reason for this is you've now machined the tread and you want the axle to run concentric with it, and to maintain that you machine that without taking it out, and then we put the hole in the middle. That then will prove that it's concentric because we've not removed it from the chuck. So the chuck can be running out slightly, but the wheel will be perfectly concentric. what I've done, the final operation there is that's a chamfer, which is 45 degrees, which will take the countersunk socket edge screw. Now that's can come out of the lathe now. And you've now got a perfectly concentric wheel ready for the next operation. The next operation, and you repeat that, of course, 6 times. Take the compound slide back to 0. But now we don't want to damage the thread that we've just machined, which these jaws will. So now remove the jaws. And what we're going to do now is we're going to put a set of soft jaws in. And these go in order. On the lathe you'll see a number 1 on the chuck, number 1 on there. You bring it down till you see the start of the thread, and they go in that way. Number 2, number 2, and number 3 goes in number 3. These soft jaws have been machined to take the angle of the wheel. We place it in like that. Prior to doing that, what I do is we set the depth that we need to go to. That's done by touching on there on the part of the chuck and just tap it back very slightly. Now we machine all that lot off. Just relocate that, make sure that it's right. Better. we're going to check the height of the flange. Now that's 166, so we need to get it down to approximately 125. So it's like 6/10. And we'll check again. That's lovely. 120. And now at that stage you can set the dial. We're not going to do that at this stage because I'm doing one wheel. You can set the dial at 0 and repeat that 6 times. Take this wheel out now. It's actually 1/2 millimetre thicker than it should be. It needs another 1/2 millimetre to come off. The reason for this is now we're going to put the square in, which is going to be done with a broach, and that will be done on a fly press. Here we are at the fly press. This is a broach which is 1/8 square, which you will take the axle, which you're probably familiar with Slater's, but we make our own, and you visually line it up. I've got lines on the fixture. I know you can't see very well, but these are the plates we call a stripper plate. That stops because we can't go straight through with the broach. So that actually stops it, takes it off. And now we've got, as you can see, you've got the corners have been knocked out. Alright, so now we go back to the lathe. What I'm going to do now is machine the rest of the metal off to make it to the right size. I've done all this before, so I know exactly where I'm going to. You'll need to obviously measure it and everything else, but I know exactly where I should be with the dimensions now. But what we do is we start by taking a cut, got that dimension. Now what I need to do now is to go into the center and come out with the tool, and the reason for that is that then you don't get any burrs on the square. And this has got to be done bit by bit. Now the next operation is the one you've all been waiting for. We're now going to expose the spokes. don't normally stop it at this stage, but I'll stop it now to show you what we're actually doing here. And as you can see, there's still a little bit of metal left in there, which I'll take out in a moment. But the idea is that you take the spokes out, and this particular, the metal that's left will support the spokes, and you've less chance of actually breaking them. It's very rare, but it does happen occasionally, and this is a good method of actually maintaining the spokes when you're machining it. So I'll just carry on now and finish it off. Again, set all your limits to the outside and inside, and repeat this again to the amount of wheels that you want to do. We'll now take it out. Let you have a look at it. So as you can see, that's now all that needs now is we need to put the crank pin in, and of course we need to insulate it if it's going to be insulated, and then we hand finish by rolling by just a very fine file and polish it up with soft emery. Right, so what we'll do now is we'll put the insulation groove in one side, in one. Alright, this is the insulation tool. These you've got to make. You cannot buy them. Sandvik won't make them for you, and they're made out of, I make them out of milling cutters which have got 8% cobalt in them. The reason for the cobalt is it's tool steel, not carbide. We've been using carbide up to now, but this is tool steel with cobalt in it. The cobalt gives it just that little bit more resistance to the cast iron. So now we're going to mount this. Turn it round this way so we can now see the front of the wheel. We position the tool. So as you can see now, you've got quite a lot of pickup surface. And when I machine the other side, you'll see what's going on. We turn it round because this is the first operation. We do the back first. Come back 2.5 millimeters. Don't get clever and go too far in. Press it hard up against, lock the saddle. There you are. It's just over halfway through the thickness of the wheel. When you're doing this operation, if you take it on, you've got to have a feel like a fairy, not like an elephant. So you can see that now. That then goes on a hot plate, heated up only slightly, and then we pour an epoxy resin in there. When it's cured off, we do the other side, and here's a wheel that we've done earlier, and as you can see, the black line, you can see the black line, and you can see the black line there. If you actually hold it up to the light, you can see through it. Okay, so that goes on there, onto the hot plate, that way up, so that all the dust falls out, so we don't get shorts. So that's the first operation to make a wheel. All right, it will be continued.